Hi, my name is Soya Park. Today I'm going to talk about our work done at IBM Research with my wonderful collaborators, Wang, Kawas, Vera, Liao, Piorkowski, and Marina Danilevsky. When building an ML model in industry, there are mainly two groups, domain experts and data scientists involved in a data science team. So domain experts are the people who are knowledgeable of the domains. For example, they're medical doctors or lawyers, and they have this desire to integrate machine learning into their workflow. But they do not know machine learning, so they are asking help to data scientists or machine learning engineers. However, they're new to the domain, but they're the people who are able to build this desired model because they're the experts in machine learning. However, due to this different background, previous research found that building a machine learning model in such a multidisciplinary team involves lots of frustration and requires lengthy time. To understand what is current practice and challenges in gaining domain knowledge between domain experts and data scientists, we interviewed data scientists and asked them how they've been building model with domain experts' help. As a result, we found that data scientists actually struggle to understand the domain, and it took several months to get familiar with the domain. And they want structured feedback and want to learn right phrase to ask questions to domain experts to gain information they want. One difficulty of building models in complicated domains is that you don't know what part of a domain is relevant. So you have no choice, but have to learn everything. One of our interviews remarked that when they build a model in legal domain, they end up becoming a semi-lawyer. And last thing is domain experts are actually busy, so data scientists cannot getting unlimited resources from them, and they have very limited time to get their domain experts' help. We are envisioning a tool to help this situation. With our tool, domain experts can provide enough domain knowledge efficiently, and data scientists can use the generate data in a way that's helpful for them to understand the domain and build a model. So we present a new system, Ziva, with zero knowledge. How do I develop a machine learning model? Ziva delivers two different outputs to data scientists, domain knowledge extraction and attention elicitation method. In domain knowledge extraction, Ziva automatically selects representative inputs. Because domain experts are busy, we want to make best use of their time and don't want to ask so many questions. Then, a domain expert can extract the topic from each input and build the information architecture of the domain. Let me give you an example in restaurant domain. Many people are familiar with restaurants, so as a preliminary study, we took a restaurant datasets to volunteers. In this case, they are domain experts of the restaurant domain. We told them, let's say you're teaching people who do not have knowledge in restaurant. Can you highlight the importance concept of the domain and teach them? As a result, even with 5 instances, they're able to come up with fairly rich domain concept and taxonomy. So for example, in restaurant, there's food, and food could be tasty, warm, or cheap, whereas service could be incomplete, overwhelmed, slow, and staff could be friendly or not friendly. To facilitate domain concept extraction, we came up with the card sorting interface where each instance of a domain dataset is a card. Domain experts can group cards together that share a topic. If each instance has more than one topic in it, users can make duplicates of a card to assign multiple topics to an instance. Secondly, data scientists want to receive structured rationale from domain experts that they can use it for modeling. So when they don't have domain knowledge, a chunk of data is hard for them to understand. Domain experts can help this by highlighting and letting focus on the relevant parts of the inputs. It allows to focus on the specific aspects of a complex input. We call this attention elicitation. To design the interface that efficiently extracts domain knowledge, we conducted paper prototyping study and let users use the prototype and see how they interact with our prototypes. So we invite volunteers and make them annotate on spreadsheets to various prompts. Had they been using it, we can see if they successfully accomplished the task or not. As we iterate the design, we ask these questions to ourselves. First, can domain experts understand the prompt? Second, we are getting consistent answers from these different domain experts. For example, we are giving 10 inputs, and the first one is, that's right, the red velvet cake. Oh, this stuff is so good. And as you can see, participant 1 and participant 2, they are returning pretty much similar answers. After we got the result from domain experts, we bring this and show this to data scientists. With their help, we enhance the prompt and do the pilot study again. We repeat this process a few times until we have reliable designs. We came up with 5 different elicitation methods, and each method is informed and inspired by interviews and literature review. I will present the interface of each elicitation method. First one is bag of words. In this method, we ask domain experts to pick keywords that indicate of a label of instance. So for example, took an hour to get our food, only 4 tables in restaurant, my pasta was lukewarm, our server was running around like he was totally overwhelmed. The keyword would be took an hour, lukewarm, and overwhelmed. And the next one is label perturbation. In this case, we are asking domain experts to change the input in a way that is no longer the previous label. So one domain expert can change it to took very little time to get our food, many tables in restaurant, my pasta was hot, our server was running around like he was totally having a blast. Next one is also sentence simplification. We also ask them to change the input. So it could be simplified to took an hour to get our food, my pasta was lukewarm, our server was overwhelmed. And the next 2 methods, we are actually using the domain concept that is extracted by the domain experts in the previous stage of the interface. So concept bag of words is we are asking to take a keywords of the extracted concept. In this case, we are asking the keywords of service is slow and food is not warm. So the keyword would be took an hour and lukewarm. Next one is concept annotation. And in this case, we are asking to get keywords of each block of the concepts. So we are asking the keyword for service, slow, food, and not hot. There are the summary of our 5 attention elicitation methods. We designed this method to help data science teams to share domain knowledge. To evaluate our system, we first take our interface to domain experts, and if they like our interface. So after conducting the task using our interface, participants were asked to fill out the NASA TLX form. As a result, backup word users think they are very successful at doing the task than the users with other interface. At the same time, backup words users are more stressed than most of the other conditions. Next, we take attention elicitation data from our domain expert study to data scientists and ask them to rank and share use cases of our elicitation data. We got a number of inspiring usage and how they will use the elicitation data in the data science workflow. For example, one of them is to build a rule-based model using elicitation data. Using domain taxonomy from Ziva, data scientists can build a concept dictionary. After this, how can you tell if each element is bad or good? To build a sentiment dictionary for each element, we can refer to attention elicitation. Hence, positive food is about tasty, warm, and cheap, and so on. Combining the concept dictionary and the attributes, we can write semantic rules to label datasets. So we actually build a rule-based model according to this idea. As a result, our attention elicitation models were reliable and robust across multiple classes than bag of words. You can find the details of implementation and result in our paper. So this was about our new system to facilitate domain knowledge learning in multidisciplinary team Ziva. Ziva facilitates the learning process by guiding domain experts to provide useful information for data scientists. Thanks for listening to my talk, and I'd be happy to take questions.